Welcome to the deep dive. We know you want to get straight to the important
Yeah.
stuff without wading through endless text. Today we're diving into API documentation.
That's right. APIs, they're like the translators between different software pieces.
Yeah.
But making sure everyone understands the conversation rules, that's the trick.
Exactly. And we've been looking at two really good blog posts from Evil Martians about this. They focus on Rails APIs,
Mm.
specifically this documentation first versus implementation first idea.
Yeah, two different philosophies, really.
So our mission today basically is to unpack the good and the bad of each. We want to help you figure out, which way might actually work best for your projects.
Let's start with the simplest one. Manual documentation. This is where developers just write stuff down after they've built the API, maybe in Notion or a Re8.0 file.
The classic build first, document later.
Yeah.
Maybe. What's the immediate problem there?
Well, the big one is it gets stale super easily. Code changes, features get added, but the docs, they often lag behind.
Right, so they become inaccurate. Pretty useless, really.
Exactly. And one of the authors was quite blunt, just called it really boring, which, probably doesn't help motivate people to keep it updated.
Huh. Fair enough. Okay, so if manual is boring and unreliable, what's next?
Okay.
You mentioned generating docs from the code itself.
Yes, the code-first approach. The idea here is you use these special mini languages, DSLs, domain-specific languages, right inside your API controllers.
Okay.
And these DSLs describe the API endpoint parameters, responses, that sort of thing. Then a tool reads that and boom, generates documentation.
Can you give me a feel for that, like in Rails?
Sure. So imagine using gems like grape and grape swagger. In your controller code where you define, say, creating a user, you'd add extra lines using their DSL.
Okay.
You'd specify things like parameter email is required, it's a string, maybe add a description or an example value, all mixed in with your actual Ruby code.
Right. And the big appeal there is because it's tied to the code, the documentation should always be accurate, shouldn't it?
That's the promise,
Yeah.
yeah. It should stay in sync. But there are downsides.
Like what? Well, first, the docs aren't actually ready until the code is written and implemented, so no early feedback.
Okay, makes sense.
Second, those DSLs can really clutter up your controllers. Lots of extra metadata mixed in with the logic. Some people find it noisy.
Yeah, I can imagine.
And, importantly, there's usually no built-in guarantee that the documentation you describe in the DSL perfectly matches what the code actually does. No automatic tests for the docs themselves.
Okay. So it helps with staleness, but introduces clutter and doesn't guarantee correctness.
Hmm.
What's the next refinement? Something about tests.
Exactly. The test-first approach. This takes those DSLs we just talked about and moves them out of the controllers and into your tests.
Ah, interesting. So you write tests first.
Right. You describe how the API endpoint should work in your test, and within that test, you use a DSL, maybe from a gem like RSwag in the Rails world, to define the expected request and response details.
Okay, so how does that look? Well, using RSpec and RSwag, you might write a test for, say, getting a list of products. In the test code itself, you'd use RSwag's DSL to say, okay, a successful response, 200, okay, should look like this. And you describe the JSON structure, the fields like name and price, their types.
And that description gets turned into documentation.
Precisely. The documentation becomes sort of a byproduct of writing thorough tests.
Okay, that seems clever. It addresses the docs only after code issue from the code first way.
Yeah.
Right. Because tests often come earlier.
It can, yes. The documentation can be generated before the final implementation is done. But it still has some potential pitfalls.
Such as?
Well, developers might still primarily focus on making the test pass and not pay close attention to the generated documentation. It can still feel a bit like an afterthought.
Right.
And the generated descriptions might not be super user-friendly. They might just use, like, the internal function names or variable names, or maybe omit details that aren't strictly needed for the test but are important for someone using the API.
Gotcha. So better, maybe, but still not quite hitting that ideal of clear, intentional, easily understood documentation. Which brings us to documentation first.
Yes, the main focus of that first article. This is a pretty fundamental shift in thinking.
How so?
The core idea is simple. You define and agree upon the API's contract, the documentation, the specification, before you write any implementation code.
Okay, so blueprint first, build second.
Exactly. And the authors even suggest calling it schema first or specification first is maybe more accurate. Because what you create isn't just documentation, it's the actual specification the code needs to adhere to.
Right. What are the big wins with this approach?
Well, because you have this formal specification up front, usually written in a standard format like OpenAPI, you unlock a whole ecosystem of tools.
Tools for what?
Generating documentation, obviously, but also
Right.
testing your implementation against the spec, validating incoming requests, creating mock servers for front-end development, even generating client-side code.
Wow, okay. That sounds powerful. What does the workflow look like then?
Typically, you'd start by drafting the OpenAPI specification. You define all the paths, the operations, GDT, PostT, etc., the request bodies, the possible responses, the data schemas. Then, crucially, you discuss this spec with the whole team, front-end, back-end, maybe product folks, analytics, anyone who needs to interact with or understand the API, get buy-in, catch misunderstandings early.
So collaboration is key.
Absolutely. Then you'd likely write tests that assert your future implementation conforms to this spec. And finally, you write the actual back-end code to make those tests pass. Or, swap the last two if you're doing strict TDD.
Okay, what are the main advantages highlighted?
First, no more DSLs cluttering your code. The spec is usually a separate YAML or JSON file, human-readable, editable by anyone.
That sounds cleaner.
Second, early feedback. You find out if the API design makes sense before you've invested heavily in building it.
Right, avoids wasted effort.
And third, the specification itself becomes a single source of truth, the contract everyone works from.
That sounds really solid. What's
Yeah.
the catch? Is there a downside?
Yeah. The main potential hurdle mentioned is the workflow change. For teams used to just jumping into code, that upfront design and discussion phase might feel like it's slowing things down initially. It requires a bit more discipline.
Right, a shift in process. The article had that Noah's Ark API example, right?
Right.
With the feed feature. How did that illustrate this?
Yeah, that was a great example. They showed starting with just a minimal valid OpenAPI document structure, then adding the paths for the feed, like feed det_t for reading, feed post for adding messages, maybe a feed message, get_t to fetch a specific one, all defined in the OpenAPI spec before any Rails code exists for it.
And they defined the details.
Yeah.
Like responses.
Exactly. They showed defining the 200 OK response for getFeed, specifying it returns application JSON, and crucially defining the schema for that JSON.
What did that schema look like?
It would say, okay, the response body is an array, and each item in the array is an object. Let's call it a feed item. And a feed item must have an id integer, an animal id integer, and message string, defining the structure and types.
You mentioned ref earlier. What's that about?
Ah, right. So instead of defining that whole feed item structure every single time you use it, like in the get_t response, maybe in the pwist request body too, you define it once in a central place in the OpenAPI doc, usually under component schemas.
Okay.
Then everywhere else you need to refer to a feed item, you just use ref, which basically points to that central definition. It keeps the spec DRY, don't repeat yourself, and much easier to manage.
Makes sense, like reusable types for your API.
Precisely. And they noted for really big APIs, you can even split the spec across multiple files and use references between them.
Okay, so you have this powerful OpenAPI spec. What's this OpenAPI ecosystem that enables?
This is where documentation first really pays off beyond just having the spec. Writing raw OpenAPI YAML can be, well, a bit tedious.
I bet.
So tools exist to make it easier, like Swagger Editor, which is web-based, or the Redocly Vs Code extension that gives you auto-completion and live previews right in your editor.
Nice developer experience improvements. What else?
Quality control. You need to make sure your specification itself is good. That's where linters like Spectral come in.
Like a code linter, but for OpenAPI.
Exactly. Spectral checks your OpenAPI document for consistency, completeness, adherence to best practices, maybe custom rules your team sets. Things like, does every endpoint have a description? Or are error responses consistent? It helps keep the contract solid.
That seems vital if it's the source of truth. What about helping other teams, like front-end?
Huge benefit there. With the OpenAPI spec defined, the front-end team doesn't need to wait for the back-end to be finished.
How?
They can use mock server tools like Prism. You feed Prism the OpenAPI spec, and it automatically spins up a server that mimics the API's behavior based purely on the definitions in the spec.
Wow. So they can build against a realistic fake API?
Yep. They can make actual HTTP requests to Prism, get back example responses defined in the spec, and build out the UI completely in parallel. Speeds things up massively.
That's a game changer. Anything else for the front end?
Type safety. Tools like OpenAPI TypeScript can read your OpenAPI spec and automatically generate TypeScript type
Oh,
definitions.
nice.
So your front-end code knows exactly what shape the data from the API will be in, catching potential mismatches early. And libraries like OpenAPI Fetch can even generate typed API client functions dynamically from the spec, reducing boilerplate code.
It really sounds like the spec becomes this central artifact everyone can use. And you mentioned nice ways to view the docs, too.
Yeah, absolutely. Once you have the spec, tools like Swagger UI, Redoc, or Elements can generate beautiful, interactive documentation websites automatically. Makes it really easy for anyone to explore and understand the API. There's a whole list of tools at openapi.tools.
And this all ties back to that collaboration point, right? The animals feed example.
Perfectly. Because they share the initial OpenAPI spec, the CEO could look at it and say, wait, that's not quite what I meant by feed, before any code got written. That early feedback loop, based on a clear shared document, is incredibly valuable.
Okay, great. So we have the spec. Now, how do we enforce that our backend code actually follows the spec? That's where schema comes in.
Exactly. Schema is a Ruby gem designed precisely for that purpose, validating that your Rails API implementation conforms to your OpenAPI document.
Okay.
It supports modern OpenAPI 3.1 and JSON schema, works with RSpec and Minitest. A solid tool for this job. They also mentioned alternatives like Committee and OpenAPI First.
So how does schema actually check the code against the spec?
You set it up in your test configuration, pointing it to your OpenAPI file. Then, in your RSpec request specs, you use its helpers.
Like what?
Key ones are conform request schema checks if the incoming request matches the spec and conform response schema status, which checks if the response for a given status code, like 200 or 422, matches the schema defined for that status in your spec.
So you use that inside a test after making an API call.
Precisely. Let's say you test p-hosting to animals.animalid feed. You make the request in your test. Then you'd write something like expect response.toConform schema 200. Schema then fetches the response your API actually generated, looks up the schema for a 200 response for that endpoint in your OpenAPI doc, and compares them. If they don't match, maybe you forgot a field or a data type is wrong, the test fails.
And it works for errors too.
Yep. If sending bad data should return a 422 error, you test that scenario and use expect response to conform schema 422 to ensure the error response structure also matches your spec. The article showed how helpful the failure messages are, pinpointing exactly where the mismatch is.
So it's basically automated contract testing baked right into your regular test suite.
That's a great way to put it. And this is what really enables test-driven development with the documentation-first approach. You have the spec, you write tests using schema to enforce the spec, and then you write the implementation code to make those spec-based tests pass.
Very cool. The first article wrapped up with some practical tips for getting started with this.
Yeah.
What were the highlights?
Yeah, some good advice. Start small, maybe just spec out one endpoint first. Definitely add spectral linting to your CI pipeline to catch spec issues automatically.
Right.
Maybe even write custom spectral rules for your team's conventions, like how errors should always look or how pagination must work. They also suggested actually reading the JSON schema specs to understand powerful keywords like unevaluated properties for security,
Right.
and mostly just reiterating the core benefits. Use it for collaboration, get that early feedback, use OpenAPI as the common language, and use schema to keep the implementation honest.
Right. So that covers documentation first pretty thoroughly. Now let's switch gears to the second article's focus. Implementation first. When might that be the better call?
So the argument there is that while Doc First is great for stability and clarity, sometimes speed is just more critical, especially for, say, startups or smaller teams finding their way.
How so?
The main advantage is that the documentation reflects what's actually built because it's generated from the implementation. You avoid that potentially time-consuming upfront design phase, allowing you to iterate faster.
Okay, so if you need to move really fast, maybe break things occasionally, this could be better.
Potentially, yes. They suggest it fits well when rapid iteration beats stability, teams are small and communicate easily, and maybe you're dealing directly with your API consumers and can just tell them about changes.
Right. Less formal contracts needed.
Exactly. When flexibility and speed are the absolute top priorities.
So if you go this route, how do you actually generate useful documentation from your Rails code? What's the mechanism?
This is where the second article gets really interesting. They talk about the standard Rails flow, models, controllers, serializers, which format the JSON output, tests.
Hmm.
And the goal is to tap into Rails' ability to understand its own structure, its models, its database schema, to automate creating that OpenAPI spec after the code is written.
They looked at some tools first, though,
Yeah,
and weren't totally happy.
right. They checked out Swagger blocks, found it had limited OpenAPI 3 support, and seemed unmaintained. A PPI Rails was maintained but stuck on the older Swagger 2.0 format. They landed on looking at RSpec OpenAPI and RSwag, which both generate OpenAPI from RSpec tests, like we discussed in the test first section. They preferred RSwag for its syntax.
But there was still a problem, even with RSwag.
Yeah, the core issue remained. Even if RSwag generated the paths and operations from tests, you often still had to manually define the response schemas within the test file itself.
Ah, so still manually describing the JSON structure.
Exactly, which is tedious and error-prone. If the actual serializer changed how the JSON looked, you had to remember to update the schema definition in the test too. It could still drift.
Okay, so they needed a way to get that schema directly from the code that generates the JSON, and that led them to Typelizer.
Bingo. Typelizer is this gem they built internally at Evil Martians. Its original purpose was actually to generate TypeScript types from Ruby serializers for front-end use.
Oh, interesting.
But then they had this clever insight. If the serializers contain enough type information to generate TypeScript, they probably contain enough type information to generate the OpenAPI schemas too.
Huh. That's smart. Reusing the same metadata. How does Typelizer get that info?
It adds a simple little DSL you can use inside your serializers. You can add lines like plus typelize string next to an attribute to explicitly tell it the type.
Yeah.
But the really neat part is, for attributes that come straight from your database columns, Typelizer can often infer the type automatically by looking at your database schema via active record.
So less manual work.
Much less. You mainly only need to add explicit typelize annotations for custom methods in your serializer or things that don't map directly to a database column.
Got it. So serializers are annotated. What are the steps to get the full OpenAPI doc generated?
Okay, step 1, annotate serializers using typelize where needed. Step 2, configure RSwag. In your swaggerhelper.rb, instead of writing schema definitions manually under components.schemas, you tell it to use Typelizer to generate them from your annotated serializers. Step 3 involves some helper client they wrote that takes Typelizer's collected information, types, nullability, array status, even database comments or descriptions, and converts it into the proper OpenAPI schema format. It leverages active record introspection quite heavily.
Clever. Using database comments as API descriptions.
Yeah, nice touch, right? Came with Rails 5. And step 4. In your actual RSwag tests, when you need to refer to a response schema, you just use ref pointing to the schema name that Typelizer automatically generated based on your serializer name. No more manual schema definitions in tests.
Wow. So RSwag handles the paths from tests. Typelizer handles the schemas from serializers.
And together, they automatically generate a complete, accurate OpenAPI document reflecting the actual implementation.
What does the final result look like?
Just a standard OpenAPI.yaml or OpenAPI.json file. It has the paths section filled in by RSwag based on your test runs, and the component schema section populated automatically by Typelizer based on your serializers and database structure.
That sounds incredibly efficient for keeping docs synced in an implementation-first world. They even used AI to help switch over.
Yeah, a neat productivity hack. They found they could feed an AI like Claude an example of a finished RSwag test, the original test it replaced, and maybe the old manual schema.
Okay.
Then ask it to convert batches of their other existing tests to the RSwag format using Typelizer refs. They stressed you absolutely need to manually check the AI's output, but it saved a ton of tedious rewriting time.
Makes sense. Now, with this auto-generated schema, how do you make sure it stays valid and you don't accidentally break the API contract?
Good question. They rely heavily on CI/CD checks. First, run Spectral, the linter, against the generated schema in CI to catch any structural or best practice issues.
Okay, validation.
Second, add a CI step that actually regenerates the schema using the Rails RSwag command, and then checks if Git sees any changes in the OpenAPI directory. If there are uncommitted changes, it means a developer changed something affecting the API but forgot to regenerate the spec, so the build fails.
Ah, consistency check.
Exactly. And third, they use a tool called OSDiff. This tool compares the newly generated schema against the version in the main branch, specifically looking for breaking changes. If it detects any backward incompatible changes, it fails the build.
So linting, regeneration check, and breaking change detection. That's pretty thorough.
Yeah, it provides a strong safety net, allowing them to move fast with implementation first while still having confidence in their API contract.
And they actually use this in production.
They did. They mentioned implementing this whole RSwag plus Typelizer workflow for WUP.com, which they described as a fast-growing platform where development speed was crucial. They said it dramatically cut down documentation time and boosted accuracy.
Okay, so after exploring both sides in detail, what's the final verdict? Documentation first or implementation first?
Well, as is often the case, it really depends. The articles make it clear there's no single best way for everyone. Documentation first, using OpenAPI upfront with tools like Schema and Spectral, seems ideal when you need stability, clear contracts, and collaboration across multiple teams or with external consumers. Think larger projects, public APIs.
Yeah.
Implementation first, especially with this kind of typelizer automation, shines when speed and iteration are paramount. Teams are smaller and communication is tight, and maybe breaking changes are more tolerable. Think early stage startups, internal tools.
So it's about matching the process to the project's needs and context.
Exactly. And what Evil Martians shared with Typelizer is a really interesting, pragmatic way to get many benefits of accurate documentation within an implementation first flow by cleverly leveraging type info that's often already there.
This has been fascinating. We've gone from basic manual docs through code first and test first to deep dives into both a robust documentation first approach using OpenAPI, Schema, and the surrounding ecosystem.
And a very sophisticated automated implementation first approach using RSwag and Typelizer to generate specs from Rails code and tests.
Hopefully you, our listener, now have a much better handle on the trade-offs and can think more clearly about what makes sense for you.
Yeah, the pros and cons should be clear, helping you choose based on things like stability versus speed, team size, who your API consumers are.
So the final thought to leave you with is this. Looking at your own projects, which end of this spectrum, or maybe which blend of these techniques, feels like it could bring the most benefit? What's one small step you could take to maybe explore that direction?
It really boils down to those trade-offs, but knowing the options, like the ones we discussed today based on the Evil Martians articles, is the first step. The quest for efficient, accurate API documentation definitely continues.